Hello students, welcome to Anne's classes. You're doing exponents, exercise 2b, questions 16 to 19. These are the questions that have been added in the new book. All the other questions except for question 1 MCQs, all the other questions are the same as the old book and it is there in an earlier video that I've made. So today we're going to be doing questions 16 to 19. This is on page number 38 and question 16 says evaluate. Evaluate means you have to add or subtract or multiply or divide based on the question. So here we have in brackets 2 to the power of minus 3 plus 3 to the power of minus 2 into 7 to the power of 0. So this is what we are going to do first. So here what does it say? 2 to the power of minus 3. That means the power is negative. When the power is negative, we can make it positive by writing the reciprocal of 2. So this is 2 by 1. It will now become 1 by 2 raised to the power of 3 and the power becomes positive. So this can be written as 1 by 2 to the power of 3 plus 1 by, here also the power is negative, so we're going to make it positive by writing 3 to the power of 2. So whenever your power is negative, if you want to make it positive, write the reciprocal of this number. So we wrote the reciprocal 1 by 2 and the powers become positive. Here also it's a negative power, so we wrote the reciprocal and the power has now become positive. Then we have into 7 to the power of 0. Now any number raised to the power of 0 is equal to 1. So this is into 1. That means all we have to do is simply solve what is within brackets. So this is 1 by 2 raised to the power of 3 is how much? So let's write that. So 1 by 2 raised to the power of 3 is 2 into 2 into 2. 2 2s are 4, 4 2s are 8 plus 1 by 3 raised to the power of 2 is 3 into 3 which is 9. So we have to work out this 1 by 8 plus 1 by 9. Let's find the LCM of 8 and 9. This is 2 4s are 8, bring down 9. Continue. 2 2s are 4, bring down 9. Then 2 1s are 2 and 9. Now we can use 3. 3, bring down 1. 3 3s are 9. Continue again. 3, 1 and 1. So what is our LCM? Our LCM is 2 into 2 into 2 into 3 into 3. 2 2s are 4, 4 2s are 8, 8 3s are 24 and 24 into 3 is 72. So that is our LCM. Our LCM is 72. Look at the first rational number 1 by 8. Now 8 into 9 is 72. So multiply this also by 9. So that becomes 9 plus the next one 9 8s are 72. So multiply 1 by 8. 1 8s are 8. So now we have 9 plus 8 which is 17. 17 by 72. So this is our answer. Question 2 under evaluate. Within brackets we have 8 raised to the power of 0 plus 2 raised to the power of minus 1 into 3 raised to the power of 2. So we're going to work out this within brackets first. So here 8 raised to the power of 0. Remember anything raised to the power of 0 will be 1 plus now 2 raised to the power of minus 1. It's a negative power. We're going to make it positive by writing the reciprocal. So that becomes 1 by 2 raised to the power of 1. So this is within brackets here into 3 raised to the power of 2. 3 into 3 that is 9. Now here let's work this out. So this will have the denominator 1. Now here in the LCM it's going to be 2. So 1 into 2 is 2. So we multiply this also by 2. So let's write 2 plus, now look at this one here. 2 raised to the power of 1 is simply 2. So we can take off that. Now 2 into 1 is 2. So we multiply this by 1. 1 1s are 1. So here we have 2 plus 1 by 2 into 9. Now 2 plus 1 is 3. 3 by 2 into 9. And we can write this as 9 by 1. So this has now become multiplication of fractions and here there's nothing to cancel. So we multiply the numerators and the denominators. So 3 9s are 27. 2 1s are 2. We can leave it at this or we can convert this to a mixed number. So 27 divided by 2. 2 1s are 2 minus 2 3s are 6 minus 1. So what do we get? We get 13 1 by 2. So your answer can be 2 1 by 2, 27 by 2 or 13 1 by 2 based on what you are asked to write it as. Question 3, here we have 1 by 6 raised to the negative power. Again we have 1 by 5 raised to minus 1 and both are subtraction and this whole thing is raised to minus 2. So first let's take each one. Now here 1 by 6 raised to minus 1 will change the power to a positive power. That means we have to write the reciprocal of 1 by 6. So let's write the reciprocal of 1 by 6. That will become 6 by 1. Now the power has become positive. Let's do the same thing with the other side. 1 by 5, let's write the reciprocal. 5 by 1. Here also the power has become positive, so that's 1. Now this whole thing is raised to minus 2. So let's write that this whole thing is raised to minus 2. Now let's work out what is inside. Now 6 by 1 is equal to 6. And 6 raised to the power of 1 is again only 6. So here what do we have? We have 6. Now here 5 by 1 is 5 and that is raised to 1 is just 5. So we have 6 minus 5 and the whole thing is raised to minus 2. 6 minus 5 is 1. 1 is raised to the power of minus 2. So again, as you can see, we have a negative power. So to make the power positive, we write the reciprocal. Now 1 is 1 by 1. If you write the reciprocal also, it becomes 1 by 1. 1 by 1 raised to the power of 2. So this is raised to the power of 2. So this is 1 by 1 square. Now 1 into 1, which is 1 by 1 into 1 is 1. So final answer is also 1. So this is our answer. Question 4. Here you can see minus 1 by 3 is raised to the power of minus 2 and that is raised to the power of 2 and that whole thing is raised to the power of minus 1. So you can see many powers here, isn't it? So whenever you have many powers like this, first work on the powers. So when a power is raised again to another power, we can multiply by using the law of exponents. So here minus 2 into 2 is what we can do. So let's do that. So let's write down minus 1 by 3. So first thing we're going to write minus 1 by 3. Now we're going to multiply minus 2 into 2. First these two powers will multiply. Minus 2 into 2 is minus 4. And this thing is raised to minus 1. This is raised to minus 1. So now what we can do is multiply these two powers. Minus 4 into minus 1. Minus into minus is plus. 4 into 1 is 4. So that becomes plus 4. So we have minus 1 by 3 raised to the power of 4. So the power is now positive. So remember, when you have to evaluate something like this raised to a power, this power is for minus 1 as well as for 3. So let's do that. So this will now become minus 1 raised to the power of 4 by 3 raised to the power of 4. So this is how it is. Now, minus 1 raised to the power of 4. Now we know this rule, we've learned this earlier. When you have a negative number that is raised to a power that is even, this is an even number, isn't it? If it is raised to a power that's even, your answer will be positive. That means instead of minus, your answer is going to become plus, and then you multiply the number 1 4 times. 1 into 1 into 1 into 1 will still be 1. Now in the denominator, we have 3 raised to the power of 4. That means you multiply 3 4 times. So here we are multiplying 3 3s are 9, 9 3s are 27, 27 into 3 is 81. So this is plus 1 by 81. So your final answer will be 1 by 81. This is your answer. Question 5. 5 raised to the power of n plus 2 minus 5 raised to the power of n plus 1 by 5 raised to the power of n plus 1. Now here we need to be very careful. It's minus, so there's nothing that we can cancel here. We need to work this out carefully. Now look at this 5 raised to the power of n plus 2. Now 5 raised to the power of n plus 2. Let me write it down here. Now when do we add powers? When do we add powers? We add up powers when the base is the same and it is multiplication, isn't it? So I'm going to reverse this now and I'm going to write this as 5 raised to the power of n into 5 raised to the power of 2. Now, if I have to write this using the law for exponents, what do I get? 5 raised to the power of n plus 2 because the base is the same. So I get this back, isn't it? I get this back. So what have I done here? Here, this is already given to me. I am putting it in this form to make my work easier. So this has now become this. It's the same thing. I've just reversed it. So let's write that here. So here I'm going to write 5 raised to the power of n into 5 raised to the power of 2 minus, same thing you can write here, 5 raised to the power of n into 5 raised to the power of 1. Again, in the denominator also we can write that 5 raised to the power of n into 5 raised to the power of 1. Now remember, if I have to use a law of exponents, I will get, since the base is the same and its multiplication, I will get 5 raised to the power of n plus 2, which is this. Again, 5 raised to the power of n plus 1, I get this. So I have just reversed it in this order. Now look carefully. Can you see 5 to the power of n is common to both? In the numerator, it's common to both. So what we can do is we can take that out separately, 5 to the power of n into, and what is left we can put it within brackets. So here I have taken the 5 to the power of n here. This from here also I've taken it out. Now I'm going to write 5 to the power of 2 inside minus 5 to the power of 1 inside. So this becomes 5 to the power of 2 minus 5 to the power of n. Now close your brackets. Now in the denominator, I already have 5 to the power of n into 5 to the power of 1. So now can you see how we got this? This is multiplication and this is multiplication. When it is multiplication, you can cancel. When it is subtraction, you can't cancel. So here I can cancel 5 to the power of n and 5 to the power of n in the numerator and denominator. So now what do I have? What I have left, I can work that out. So in the numerator, I have 5 to the power of 2, which is 5 into 5, which is 25. 25 minus, now here I have 5 raised to the power of 1, which is simply 5. And in the denominator, again I have 5 raised to the power of 1, which is 5. So 25 minus 5 is 20. In the denominator 5. Now divide 20 by 5. 5 fours are 20. So what do I get? I get 4, which is my final answer. So you should be careful when you work out these steps. Question 17. Find the value of x if these two are equal. The left hand side is equal to the right hand side. So now let's look carefully at our question. Here we have 125. Here we have 5. And both are raised to a power. Now we can apply our laws of exponents if the bases are the same, isn't it? Here the base is not the same. So can we make 125 have a base that is 5? Let's find the factors of 125. So if I take 125 divided by 5, 5 2s are 10, then there's 2 left here. So 25, 5 5s are 25. Now continue. 5 5s are 25 and 5 1s are 5. So I can write, instead of 125, 5 raised to the power of 3. So let's write that here. So now this becomes 1 by 5 raised to the power of 3. So that is in place of 125, and this whole thing is raised to the power of x minus 7. On the right hand side, I have 5 raised to the power of 2x minus 1. Now here what we can do is, whenever you have a power raised to another power, you can multiply by using the law of exponents. So let's multiply. So 1 will remain the same, and here we have 5 raised to the power of 3 into x minus 7. So let's do that multiplication here. 3 into x minus 7. So first we multiply 3 into x, which is 3x, and then we multiply 3 into minus 7, which is minus 21. So this becomes 5 raised to the power of 3x minus 21. On the right hand side, we have 5 raised to the power of 2x minus 1. Now here you can see reciprocal, isn't it? Now if we take 5 to the numerator, that means we are writing the reciprocal of 1 by 5. It's going to become 5 by 1. Whenever you write reciprocals, the sign of the powers will change. Okay, so first let's write the reciprocal of 1 by 5. So that will become 5. Now look at this power 3x minus 21. I'm going to take it also up. So let me write it as 3x minus 21. But since I've written the reciprocal, this sign will change to minus. And this is equal to 5 raised to the power of 2x minus 1. No change in this. So now let's open the brackets here. So minus into plus is minus. So that is minus 3x. And then we have minus into minus, which is plus 21. Plus 21. So this is equal to 5 raised to the power of 2x minus 1. Now can you see, children, here the base has now become the same. If bases are equal, that means the powers are also equal. So we are going to make this equal and find the value of x. So I will continue this here. So let's take only the powers, which is minus 3x plus 21 is equal to 2x minus 1. I hope you understood this part. When the base is equal, then the powers also are equal. That's why I wrote minus 3x plus 21 is equal to 2x minus 1. Now let's take all the x's to one side. So here we have minus 3x. We bring 2x from the other side. We're going to bring it here, so that becomes minus 2x. And there we already have minus 1. We're going to move this plus 21 to the other side. It becomes minus 21. So this is now equal to minus 3x minus 2x. Signs are the same. Put the same sign and add. 3 plus 2 is 5. Minus 5x is equal to minus 21 plus 1 is 22. Then we can find the value of only x. X is equal to minus 22. Now here 5 into x, it's multiplication. So we're going to take it to the other side. It becomes division. So we're going to divide this by minus 5. So this is minus 5. Now minus and minus get cancelled. So x is equal to 22 by 5. So this is our final answer, 22 by 5. Question 2. 2 by 3 raised to the power of 3 into 2 by 3 raised to the power of minus 4 is equal to 2 by 3 raised to the power of 2x plus 1. We're going to find the value of x. Now here can you see the base is the same and it is multiplication. So we can apply the law of exponents and we can add up the powers. So this will be 2 by 3. The whole thing is now raised to the power of 3 plus minus 4. Which is equal to 2 by 3. This remains the same, no change. 2 by 3 raised to the power of 2x plus 1. So this now becomes 2 by 3. Now here look at this. 3 plus minus 4, that is 3 minus 4. So 3 minus 4. This is equal to, on the right hand side, no change. 2 by 3 raised to the power of 2x plus 1. Now this is 2 by 3 raised to the power of 3 minus 4 is minus 1. And this is equal to 2 by 3, the whole thing raised to the power of 2x plus 1. Now can you see that the bases are equal? If the bases are equal, that means the powers are also equal. So here what do we get? We get minus 1 on the left hand side. This is equal to 2x plus 1. So I'm just moving this to the other side. That is, I'm writing 2x plus 1 on the left hand side equal to minus 1. This is just to make our work easier when we have the unknown quantity on the left side. Same thing, I've just interchanged the sides. Now I'm going to leave 2x on the left hand side itself. On the right, I have minus 1. I'm going to transpose this plus 1 to the other side. It's going to become minus 1. So now 2x is equal to minus 2. Therefore, x is equal to minus 2 by 2, which is equal to minus 1. So we have our answer. Minus 1 is our answer. Question 3. 4 to the power of x divided by 4 to the power of minus 3 equals 4 to the power of 5. So here the base is the same and it is division. We can use the law of exponents where we have to subtract the powers when it is division. So this will become 4 raised to the power of x minus 3. It is equal to 4 raised to the power of 5. So this is now 4 raised to the power of x minus into minus is plus x plus 3. So this becomes x plus 3, which is equal to 4 raised to the power of 5. So now again the base is the same, so the powers will be equal. So now let's take only the powers, that is x plus 3 is equal to 5. Now we can find the value of x. We can say x is equal to 5 and we'll transpose this to the other side. It becomes minus 3. So now the value of x is equal to 2. 5 minus 3 is 2 and this is our answer. Question 18, simplify. Now here we have to be very careful. Now look carefully children and see if you have any number which is not a prime number. Let's simplify that and put it in the form of prime numbers. Now 81 is not a prime number, 9 is not a prime number, 3 is a prime number. Let's see if we can put it all in the form of 3's. So what we'll do is we'll take 81 and let's use prime number 3. Let's look for all the prime factors. So this is 3 2's are 6 and then there is 2 left, 21, 3 7's are 21, then 3 9's are 27, 3 3's are 9 and 3 1's are 3. So 81 can be written as 3 raised to the power of 4. So here let's write that. So here it is 3 raised to the power of 4. Then we'll continue into 3 raised to the power of n plus 1 minus now 9 also. Let's see if we can find the prime factors. 3 3's are 9, 3 1's are 3. So 9 can be written as 3 raised to the power of 2. So this is going to be 3 raised to the power of 2 into 3 raised to the power of n. Now similarly in the denominator, 81 we know is 3 raised to the power of 4 into 3 raised to the power of n plus 2 minus 9 is 3 raised to the power of 2 into 3 raised to the power of n plus 1. Now let's go slow with this. So I'm going to write 3 to the power of 4 as it is into, now look at the next one, it is 3 to the power of n plus 1, isn't it? Remember, when do we add the powers? When the base is the same and it is multiplication. So I can reverse this and write this as 3 to the power of n into 3 to the power of 1, isn't it? Now if I have to use the law of exponents, what will I get? 3 to the power of n plus 1, which is this. So from here I have made it this. We did this in an earlier sum also. So I'm going to write this here. So let's write that. So that is 3 to the power of n into 3 to the power of 1 minus. So this much I have finished. Now I'm continuing minus 3 to the power of 2 into 3 to the power of n. 3 to the power of 2 into 3 to the power of n. And in the denominator, what do I have? 3 to the power of 4 into. Now this also 3 to the power of n plus 2. Let's break it up like this and write. So that will be 3 to the power of n into 3 to the power of 2. Continue minus 3 to the power of 2 into. Let's break up this also. So it will be 3 to the power of n into 3 to the power of 1. So 3 to the power of n into 3 to the power of 1. So I hope all of you have understood till here. Now, when it is multiplication, we can add up the powers, isn't it? So let's add up the powers of 4 and 1 here, not n, because we have to find that value. So this is going to be 3 to the power of 4 plus 1 into 3 to the power of n. So what have I removed? I've removed 3 to the power of 4 plus 1 into 3 to the power of n. Now I can continue with this. So this is minus 3 to the power of 2 into 3 to the power of n. Now in the denominator also I can do the same thing. I can say 3 to the power of 4 plus 2. 4 plus 2 and I'm going to leave this as it is. So that will be into 3 to the power of n minus 3 to the power of, here also I can add up 2 plus 1 into 3 to the power of n. So now what do I get? After adding, I get 3 to the power of 5 into 3 to the power of n minus 3 to the power of 2 into 3 to the power of n by 3 to the power of 6 into 3 to the power of n minus 3 to the power of 3 into 3 to the power of n. Now there is a chapter called factorization which you will be learning soon, which I'm going to apply here. Okay, so here what we do is, let's see what is common. As you can see, in this first part we have 3 to the power of 5 into 3 to the power of n. minus, in the second part we have 3 to the power of 2 into 3 to the power of n. What you can see very clearly which is common is 3 to the power of n, isn't it? So let's do that. Now I'm going to continue here. So here I'm going to take out the common one, which is 3 to the power of n. So first let me take out 3 to the power of n. Now I can still take out, here I have 3 to the power of 5 and 3 to the power of 2, isn't it? So if I take out only 3 to the power of 2, that's there here also, isn't it? Because this is 3 to the power of 5. So let me take 3 to the power of 2 out. So into 3 to the power of 2, and the rest of it I'm going to put it within brackets. So let's look at this. This is 3 to the power of 5 and I already have 3 to the power of 2 here. So how much is left? 3 to the power of 3. So let me write that inside the brackets, 3 to the power of 3. Then I have into 3 to the power of n, which is already outside the brackets. Then I have minus, so let me write minus there. Then here I have 3 to the power of 2, which I already have outside. So instead I'm going to write 1, okay, because I already have it outside. Into 3 to the power of n, I already have 3 to the power of n outside. So let me explain that once more. So here we have all these, isn't it? Pick out the common one. What is common is 3 to the power of n, which I have taken out. So I don't have to write it inside anymore, inside the brackets anymore. Then I have 3 to the power of 5 and 3 to the power of 2. In that I'm taking the minimum one, not the maximum. The minimum is 3 to the power of 2. That I'm putting it out. Now the rest of it, I have to put it inside the brackets. So let's start with this. Here 3 to the power of 5. I already have 3 to the power of 2 outside, so I write the remaining. Then I have 3 to the power of n, which is already outside, so I just have to write minus. I don't have to write it. Then I write minus, and let's check this. 3 to the power of 2 is already outside, so I just have to write 1 there. So 1 into that will give me that back. 3 to the power of n is outside, I don't have to write. Now let's do the same thing with the denominator. Let's pick out the common ones. 3 to the power of n is common, so first let's write that 3 to the power of n. Into, again here also I have 3 to the power of 6 and 3 to the power of 3. Take the smaller one, that is 3 to the power of 3, and write it outside. 3 to the power of 3. Now the remaining will come inside. So let's look at the first one. 3 to the power of 6. I already have 3 to the power of 3 outside. So what is remaining? Only 3 to the power of 3. So that will become 3 plus 3, that is 6. Then let's look at the next one. 3 to the power of n, which is already there. Then let me write minus. Then I go to 3 to the power of 3, which is already outside, so I can write 1. Then the last one is 3 to the power of n, which is already outside. So now I have got it in this form. My work is going to become easier. Now, since all this is multiplication, we can cancel easily. So first I can cancel 3 to the power of n and 3 to the power of n. So let's cancel these two. Now look at this. 3 to the power of 3 minus 1, 3 to the power of 3 minus 1 also can be cancelled. It's the same thing because it's multiplication. Now I have 3 raised to the power of 2 by 3 raised to the power of 3. That's the only thing that's left. 3 square and 3 cube. Now here again, because the base is the same, we can use the law of exponents and subtract the powers. 2 minus 3, which is 3 to the power of minus 1. Now to make the power positive, we can write the reciprocal, that is 1 by 3 to the power of 1, which is 1 by 3. So this is our final answer. So this sum is a little complicated, children, but go carefully step by step and you will come to your final answer. Question 19. If 2 raised to the power of n minus 7 into 5 raised to the power of n minus 4 is equal to 1250, find n. Now here we have two prime numbers raised to a power. Now here we don't have a prime number, so let's try and find the prime factors of 1250. So 1250, let's divide by 5. 5 2s are 10. There's 2 left, so 5 5s are 25, 0. Continue. We'll use 5 again. 5 5s are 25, 0. Then continue. 5 10s are 50. Then 5 2s are 10. Now we can use 2. 2 ones are 2. That means 1250 can be written as 5 raised to the power of 4 into 2 raised to the power of 1. So now this is equal to 2 raised to the power of n minus 7 into 5 raised to the power of n minus 4, which is now equal to, instead of writing 1250, we can write 5 raised to the power of 4 into 2 raised to the power of 1. Now, since both sides are equal, this is equal to this side, we can take the numbers with the same base. So I can take this and this together. So that means 2 to the power of n minus 7 is equal to 2 to the power of 1. So let's write that. So this is 2 to the power of n minus 7 is equal to 2 to the power of 1. So I've taken only the 2's. Now let me take the 5's. So here let me write 5 separately. So 5 to the power of n minus 4 is equal to 5 to the power of 4. So first let's work out what we have with 2 with the base 2. So now we know that when the bases are equal, the powers are also equal. So n minus 1 is equal to 1. So let's write that n minus 1, n minus 7 is equal to 1. So to find the value of n, we can say 1 plus 7, because we are transposing 7 minus 7 to the other side, it becomes plus 7. So here we have found the value of n to be 1 plus 7, 8. So here we have found the value of n to be 8. Let's try with 5 here. So here we have 5 raised to the power of n minus 4 is equal to 5 raised to the power of 4. The bases are equal, so the powers also are equal. So this will be equal to n minus 4 is equal to 4. So now to find the value of n, we say 4, and then we're going to transpose this minus 4 to the other side. It becomes plus 4. So here also n is equal to 8. So can you see? Here we found n to be equal to 8, and here also it's 8. That means the value of n is 8. So with this, children, we have come to the end of all the new questions in the new book. And all the other questions are the same as in the old book. So thank you, children.